Hello, I'm Ed Murphy with the Astronomy Department at the University of Virginia, and this is Astronomy 1210, Introduction to the Sky and Solar System, Lecture 23, Exploration of Our Solar System. Well, we're beginning the second half of our class, which is a tour of the solar system and all the bodies that make up our solar system. And for this very first lecture on our solar system, I thought I would take a quick but grand tour of all the objects, at least the major objects in our solar system, and do that through the lens of exploration. That is, what robots do we have out there in the solar system right now? What are we learning? And what are some of the future plans? So let's begin with just a quick look at the solar system. I really like this image from the International Astronomical Union, and it was published just after Pluto was demoted from being a planet down to a dwarf planet. And it shows you the major bodies in our solar system. Now, I'm not a stickler for whether there are 8 planets or 9 planets or 15 planets in the solar system. I was fine with Pluto being demoted from planetary status because it is smaller than our own moon. It is just one of many of thousands of cold, icy bodies out there at the edge of the solar system. And there are at least a few icy bodies that we know of that are about the same size as Pluto. And so I was happy, I was fine, I should say, with the demotion of Pluto down to being a dwarf planet. And right now in astronomy, that leaves us with 8 major planets in the solar system. And you should know the order of the planets from the sun outward. It's almost guaranteed that there will be a question about this on one of the upcoming quizzes. So make sure that you memorize or at least know the order of the planets. They are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and if you would like, you can include Pluto. So the way to remember this is probably one of the more famous mnemonics is my very earnest mother just served us nachos, or my very earnest mother just served us 9 pizzas, if you want to include Pluto. So that's the way you can remember the order of the planets from the sun out. Now, I like this diagram because it also shows the correct scale of the planets relative to one another. So Jupiter, Saturn, Uranus, and Neptune are the gas giant or Jovian planets in our solar system. And they are made primarily of gas. They're made mostly of hydrogen and helium gas. They're made of the same gases as the sun. They are just much, much smaller than the sun. And they don't have the nuclear fusion going on down at their centers that's required to be a star. Mercury, Venus, Earth, and Mars, on the other hand, are the small terrestrial or rocky planets. Earth is the largest of the terrestrial planets. Venus is almost a twin to Earth in terms of size. And then we have Mars, and Mercury is the smallest. And then out here at the edge of the solar system, we have the cold, icy planets. So instead of memorizing whether there are 8 planets or 9 planets or 15 planets, depending on what you want to classify as a planet or not, I think it is much more important that you understand there are 3 kinds of planets. The hard, rocky planets, called the terrestrial planets, the gas giant planets, called the Jovian planets, and then the cold, icy bodies out here at the edge of the solar system. Now, although this plot shows a great job of showing you, first of all, the differences between planets and stars. Stars, of course, are huge. They're enormous. Planets are much smaller. And it also does a good job of showing you the relative sizes of the planets compared to one another. It does not do a good job of showing you the distances from the planets to the sun. And that's what this diagram is for. So this diagram shows us the sun, Mercury, Venus, Earth, and Mars going in order out from the sun. And what's important to know about all of these planets is that they are found in the very inner solar system, very close to the sun. In fact, Mars is 1.5 astronomical units from the sun. Of course, Earth is 1 astronomical unit from the sun. Venus is about 0.7 and Mercury is about 0.4. So between the sun and 1.5 astronomical units from the sun, we have all the terrestrial planets. The gas giants are spread out much further in the solar system. Jupiter is 5 times further from the sun than we are. That is, it's 5 astronomical units from the sun. Saturn is about 9.5 astronomical units from the sun. Uranus is 19 astronomical units from the sun. Neptune is 30, and Pluto is 39 astronomical units from the sun. So keep in mind that these planets in the outer solar system are really quite spread out. I mean, a really good example of this is all of the terrestrial planets are within 1.5 astronomical units of the sun. We could fit 3 of those between the sun and Jupiter. That is, we could fit all the terrestrial planets 3 times out to Jupiter. And the whole solar system out to Jupiter would fit between the orbits of Jupiter and Saturn, because Jupiter is 5 astronomical units from the sun, Saturn is almost 10. Everything out to Saturn would fit between Saturn and Uranus, because Uranus is almost 20 astronomical units from the sun. And everything out to Uranus would also fit between Uranus and Pluto, because Pluto is almost 40 astronomical units from the sun. So the planets here in the outer solar system are very, very spread out. The distance from Saturn to Uranus is about 10 astronomical units, another 10 out to Neptune, and another 10 out to the average distance of Pluto. So keep in mind that the terrestrial planets are packed close to the sun. The gas giant planets are spread further out, and out here at the very edge of the solar system, we find the cold, icy bodies. Here's a chart showing some of the general properties of the planets in our solar system. Don't worry about memorizing this. We'll go over some of the important details, but a couple things that I want to draw your attention to here. Here are the distances from the sun that I mentioned a minute ago. And you can see that Mars and everything else is very close to the sun compared to the outer solar system. The other thing I want to draw to your attention is the planet Jupiter. It's really quite amazing. Jupiter's 11.2 times the diameter of the Earth, but most importantly, it's almost 318 times the mass of the Earth. And if you look at all the other planets and add them together, they don't add up to the mass of Jupiter. In fact, if you add all the planets together, they don't even add up to half the mass of Jupiter. And the important thing to know about Jupiter is Jupiter has as much mass, has actually, in fact, twice as much mass as all the other planets put together. It is, by far, the dominant planet in our solar system. And Saturn, interestingly, is less than a third the mass of Jupiter, but it's almost the same size as Jupiter. And then Uranus and Neptune are significantly smaller again. So that's the mass of each body. Later on, we will also talk about the density of the body. And of course, density is measured in this case here, in terms of the density of water, which is 1 gram per cubic centimeter. So these bodies here are very dense. These are much less dense, and these are intermediate out here at the very edge of the solar system. So you can look over this chart if you would like, just to learn about some of the planets. So, Saturn is 9 times the diameter of the Earth. Uranus is 4. Neptune is a little bit less than 4. Interestingly, Neptune is more massive than Uranus is, even though it is smaller in size. So there's some interesting things out there in the solar system. But like I said, I don't expect you to memorize these numbers, but do take a look at them and know the trends for the numbers. Okay, so there are the planets in our solar system. I thought what we would do is take a tour through the solar system and talk about some of the robotic exploration that's going on out there in the solar system right now. So the first thing I thought we would talk about is the sun. Being the dominant body in our solar system, we depend on the sun for energy. We also have to worry about the sun because of huge solar flares. They could disrupt communications on Earth. They can destroy satellites. So we need to keep a close eye on the sun. And the sun is being watched very closely, I should say, in a number of different ways. So let's start, first of all, with all the robots in the solar system right now. This is a terrific plot by Olaf Frone, which shows all the robots in our solar system that are out there right now. And I think the first thing is people are surprised by how many we have out there in the solar system. I would argue that right now we are living in the golden age of solar system exploration, where we have more robots out there doing more things than we really have at any point in human history. The solar system is absolutely full of robots that are out there studying the planets and bodies in the solar system. And we'll go over some of them. We certainly won't go over all of them. But let's very quickly talk about the sun. So the first thing I want to mention about the sun is that between the Earth and the sun, at a special point called the Lagrange point, the L1 point, there are a whole bunch of satellites sitting there whose job it is to study the sun. The L1 point is quite special. It's a place where the gravity between the Earth and the sun and the orbital motion all balance one another out, so that if you put a satellite at the L1 point, it'll stick with the Earth as the Earth orbits the sun. Normally, an object closer to the sun than the Earth will orbit faster than the Earth, and it should pull out ahead of us. But in this particular case, because of the gravity of the Earth pulling outward, reducing essentially the gravity from the sun, these particular objects at this one particular point all sit still. That is, they sit at the Lagrange point, and they follow the Earth as we go around the sun. And a bunch of these are out there studying the sun. So there's SOHO, the Solar Heliospheric Observatory, and ACE, the Advanced Composition Explorer, and WIND, which is the oldest of them. It was launched back in the 1990s to study the solar wind particles coming from the sun. So there are all these solar observers out there between the Earth and the sun, keeping an eye on the sun. At the same time, we also have two probes that are getting an up-close look at the sun. And those two probes are the European Space Agency's Solar Orbiter, which was just recently launched into space, and the Parker Solar Probe, the United States NASA Parker Solar Probe. So the Parker Solar Probe, the goal for this is to get closer than we have to the sun, closer than we've ever gotten in all of history. But it's a very challenging mission to carry out because, of course, the sun is extremely hot. So the spacecraft itself was specially designed to have a huge sun shield. And the spacecraft, as it passes close to the sun, hides behind the sun shield because should the spacecraft be exposed to the direct light coming from the surface of the sun, the spacecraft itself would overheat and would shut down. And so there's a huge shield that is protecting, sun shield, that is protecting the spacecraft from the sun. The solar arrays can also fold in and out. When they are close to the sun, they fold them back to keep them from getting too hot. But as the Parker Solar Probe pulls further from the sun, they can move the solar arrays back out to generate energy. On June 9th of 2020, the Parker Solar Probe passed just 11.6 million miles from the sun. And at that moment in time, it was traveling 244,225 miles per hour. And that makes it the fastest object that humans have launched, and it makes it the closest object that we have brought to the sun. Now, the Parker Solar Probe is on a highly elliptical orbit that takes it close to the sun. Well, let's start up out here. When it was launched from Earth, we had a rocket that was large enough to launch it to the inner solar system, but we couldn't get it as close to the sun as we wanted. So the Parker Solar Probe has a number of flybys of Venus, and as it flies by Venus, it uses those flybys to change its orbit, to reduce the size of its orbit, to bring it closer and closer to the sun. And in fact, it still has flybys of Venus scheduled to reduce its orbit to bring it closer to the sun in the future. But it's on this highly elliptical orbit that brings it out beyond the orbit of Venus, and then it falls back in towards the sun, and it spends roughly about 10 days to 2 weeks close into the sun here doing observations, and then it flings itself, I should say its orbit brings it back out again, and then it on the next orbit down, it does it again. So that is the Parker Solar Probe. And I mentioned some of these other missions, the Solar and Heliospheric Observatory, the Solar Dynamics Observatory. That one is in geosynchronous orbit around the Earth studying the sun. The Advanced Composition Explorer, which is also looking at the particles that the sun gives off. One that I didn't mention is the STEREO mission. STEREO was a very clever idea. One disadvantage we have with all of our satellites here is we can only see the sun from one direction, which means we only see one face of the sun. We don't know what's going on the other side of the sun. So NASA launched two satellites, STEREO A and STEREO B, and they are in the same orbit that the Earth is, but one of them is moving a little bit ahead of the Earth in its orbit, and one is moving a little bit behind the Earth in its orbit. And STEREO A and STEREO B can see the far side of the sun. So as the Earth goes around the sun, the two of them are looking at the far side. Now, unfortunately, STEREO B is no longer working, but the STEREO A spacecraft is still in operation. So that's a little bit about what's going on at the sun. I just wanted to show you this really cool movie that comes from the Solar Dynamics Observatory to show you the kind of things that they're doing. This is a 4-hour movie of the sun. So this is all the activity on the sun in this series of 4 hours. This particular movie was made using ultraviolet light, extreme ultraviolet light. It had a wavelength of 305 nanometers. That puts it far into the ultraviolet portion of the spectrum. And it shows us the activity going on in the solar atmosphere. It shows us beautiful prominences, which are these arcs and loops reaching above the surface of the sun. We'll see a flare go off down here. That bright flash was a flare going off. You can see the influence of the sun's magnetic field. You can see a tremendous amount of detail in this. These are the kinds of things that scientists are using to study our sun. But that is our sun. Let's move on to the planets in our solar system. So as we start with the planets in our solar system, let's start at the inside and move out. And let's talk about Mercury for a second. Currently, Mercury does not have any spacecraft studying it. In fact, it's only been studied up close by 2 spacecraft. The Mariner 10 spacecraft, way back in 1974, flew by Mercury 3 times. And then the United States launched the Messenger mission to Mercury. And Messenger operated for about 5 years or so in orbit around Mercury, teaching us all about the surface. And this particular photograph comes from the Messenger mission. And looking at it, it looks remarkably like our moon. It is covered in craters. And this is largely because Mercury has no atmosphere, like our moon has no atmosphere. We will talk later on this semester about why some planets and moons have atmospheres and why some of them do not. Mercury is one of those that does not have an atmosphere. This is another image that was taken by the Messenger mission, but showing you a little bit about how scientists study these planets. The Messenger mission not only took color photographs, but it had special color filters that were tuned to certain wavelengths of light, certain colors of light that different minerals give off and absorb, and that they emit, they reflect, or they absorb. And from this, Messenger was actually able to map out the mineralogy of the surface of Mercury. So not only do we know what the surface looks like, but we also have a good idea of what the composition of the surface is. And I love this multicolor image showing you that a body that looks fairly gray and dingy and covered in craters really has a complex geological history to it. A beautiful example of this is this huge impact basin up here. That's a giant impact crater on Mercury. Lots and lots of other interesting things that you can see about Mercury. Right now, there is a new mission on the way to Mercury. It's called Bepi-Colombo. It was launched by the European Space Agency last year. Bepi-Colombo is on its way to Mercury, and it should arrive in Mercury. It was launched in 2018, and it should get to Mercury in 2025. So that is the Bepi-Colombo spacecraft. There are 2 parts to the spacecraft. When it gets to Mercury, it's going to split into its 2 different parts and study the planet. All right. The next planet out in the solar system is Venus. And so let's talk about what's going on at Venus right now. Venus is an interesting planet because it is completely shrouded in clouds. It is the brightest of all the planets as seen from here on Earth, and that is twofold. One reason that it's really bright is because those clouds are really good reflectors of sunlight. They do an excellent job reflecting sunlight. The other reason it's the brightest planet as seen from Earth is because Venus is nearby. It gets closer to us than any other planet. It comes within 1/4 of an astronomical unit of the Earth. But those clouds present a problem for astronomers in that we can't see through the clouds. So if we want to map the surface of what Venus looks like, we have to use radar missions. And we have done this in a number of different ways. We have used radar from Earth, where you literally send radio waves out from Earth. They take a couple minutes to get to Venus. They bounce off the surface and they come back. But primarily, we've mapped Venus through a NASA mission called Magellan that operated in the 1980s and 1990s. And Magellan mapped the surface of Venus using radar, bounced radar waves off the surface and mapped the surface of Venus. Like the Earth, Venus seems to have high-lying continents and low-lying areas. The difference is on Venus, these low-lying areas are not covered in liquid water. As we will see later on in the semester, because of its very thick atmosphere trapping all the heat down on the surface, Venus is actually the hottest planet in our solar system. Now, in orbit around Venus right now is a Japanese spacecraft called Akatsuki. Akatsuki is a fascinating mission. It was supposed to arrive at Venus in 2010. It fired its main engine to slow down to go into orbit around Venus, but after only 3 minutes, it shut itself down and it flew by Venus too quickly to get into orbit. Akatsuki was then in orbit around the Sun. And Japan, who had launched the Akatsuki mission, was trying to figure out what to do, and they found that in 5 years it would return back to the vicinity of Venus. And so 5 years later, they had a second attempt at putting it into orbit. This time, though, they couldn't use the main engine because it was out of service, so they had to use the thrusters on board, but they were able to slow the spacecraft down enough that it was able to get into orbit around Venus. And since 2015, Akatsuki has been studying the atmosphere on Venus. Now, we have landed on Venus a number of times, or I should say at least the former Soviet Union has landed on Venus a number of times, and that was with the Venera, or Venus spacecraft. One of the more famous missions is Venera 13. It landed, soft landed on the surface of Venus, and it lasted for 2 hours and 7 minutes on the surface. It seems like a lot of trouble to go through for just 2 hours and 7 minutes on the surface, but it just goes to show you how hot the surface of Venus is. Probably about 800 degrees Fahrenheit or so. Hot enough that spacecraft and computers just cannot survive in those temperatures for very long. So it had an interesting camera on board. That camera looked down at the bottom of the spacecraft and then would scan sideways one way and sideways the other way to take photographs. So here we are looking at the base of the spacecraft here, and then the camera scans out and we see out to the horizon in one direction, and then it scans out and we see out to the horizon in the other direction. So the color of this image is how Venus would appear under Earth lighting. Under the actual lighting that we find on the surface of Venus, because of its very, very thick atmosphere, all the blue light is scattered away and only the red light makes it down to the surface. So if you were standing on the surface of Venus, it would be very dim and everything would be very dim and very red in color, because only the long wavelength red light makes it down to the surface. Some amateur scientists have rectified these images. They've taken the images that the Soviet Union produced and they have sort of straightened them out so that they're not on that odd little twisting motion right there. And these are some of the images of what the surface of Venus looks like. Venus is covered in basaltic lava flows, and what we are looking at here is the spacecraft having landed on some of these solidified lava flows. All right. We're not going to spend much time talking about spacecraft studying the Earth, because there are literally hundreds of spacecraft in orbit around the Earth. Many of them are communications satellites, but there are dozens of weather satellites and Earth observation satellites that are constantly looking down on our planet. That said, I do for a moment, though, want to talk about our moon, because our moon is one of the more interesting bodies in the solar system, and there's a tremendous amount of work being done at our moon right now. First and foremost, NASA is operating the Lunar Reconnaissance Orbiter. It has the highest resolution camera that we have ever put in orbit around the moon. So to give an idea of the kinds of things the Lunar Reconnaissance Orbiter can see, this is the Great Crater Tycho. It's one of the youngest, freshest craters on the moon, or Tycho. It's named after Tycho Brahe, who we saw just a couple lectures ago, the famous astronomer. And the crater Tycho is about 60 miles across from side to side. So if we were standing on this side right here, the other side would be about 60 miles to the other side, about 100 kilometers from side to side, maybe a little bit less than that. And sitting down at the center of the great crater is a huge mountain. The spacecraft has taken a close-up image of that mountain, so as it flew over the crater, it used its camera to take an oblique angle, which means not looking straight down, but looking off to the side. And here is that mountain, that central peak. We will find out later on why massive craters like this have central peaks. It's called isostatic rebound. It has to do with material returning upwards, bouncing back upwards after the crater is excavated, immediately after the crater is excavated. The bottom of the crater here is filled with what used to be molten rock called impact melt, and we can see it all around the mountain right here. These are giant chunks of rock and rock that had been molten that all sloshed back into this crater and fell down into the crater right after it was created, but was molten at the time and has since solidified. What's most interesting about this mountain, and sitting up on top of the mountain right there, is a giant block. And to show you the kinds of images we're getting back, that is an image of that block right there. Now that block, that huge rock that happens to be perched right on top of that mountain, that rock is about the size of a good-sized building here on Earth. So that thing is not small. You see some impact melt right here, and then there was the mountain that was thrust up in creating the crater. To give you another idea of the kinds of images that the Lunar Reconnaissance Orbiter is returning, here's a photograph of the Apollo 11 landing site. So not only can we see the remnants of the lunar module here, the descent stage of the lunar module was the launch pad for the ascent stage and was left behind on the surface. So that is the lunar module right there. And then over here are some of the scientific experiments that were left behind. The laser retroreflector right there is, I had mentioned in the last lecture on tides that astronauts left behind devices that had prisms in them called corner cubes, that when you shine light on them, the corner cube immediately reflects the light that comes back to Earth. And that is one of those laser retroreflectors that was left behind. Another scientific experiment that included a seismometer, the camera over here. You can even see where during the Apollo 11 moonwalks where Neil Armstrong had a few extra moments while Buzz Aldrin was packing things up and working on things over at the lunar module. Neil Armstrong had a few minutes and he wandered off and wandered all the way over to this crater and then wandered back again. Those are the footsteps of Neil Armstrong on the surface of the moon. Really quite remarkable photographs. All right. In addition to the Lunar Reconnaissance Orbiter, there is a robot, a rover, operating on the surface of the moon right now, the Chang'e 4 rover that was launched by China. It landed on the far side of the moon in January of 2019 and has been operating ever since. So there is the lander portion of it. The rover was mounted on top of the lander, and then it drove off a ramp on the lander down onto the surface and has been driving around on the surface since. China is planning for 2020 to launch a sample return mission to the moon, to land on the moon and bring samples back to Earth. The moon has gotten a lot of attention from other nations in recent years. So Israel tried to do a soft landing in April of 2019. They had built and launched a spacecraft to the moon called Beresheet. But unfortunately, Beresheet crashed just above the surface of the moon. It lost attitude control. And by the time they regained attitude control, it was too low and going too fast. And it ended up crashing into the surface of the moon. But Israel tried to land a spacecraft on the surface of the moon. Here are two images that show you the before and after of the impact site. So if you look right here, you can see where the lander crashed into the surface of the moon. So you can see the before image, and at the after image, you can see some of the disturbed soils around it. Israel is not the only country that is trying to land on the moon. Israel also tried to launch a mission to the moon called Chandrayaan. And Chandrayaan crashed in September of 2019 on the surface of the moon. So both Israel and India have said that they are going to try again. Now, the United States is planning to return astronauts to the moon. We are building a giant rocket right now called the Space Launch System, which will not be used to bring astronauts to low Earth orbit, but is going to be used to bring astronauts to the moon and possibly destinations beyond the moon, possibly even Mars in the long distance future. But the NASA Space Launch System, it will be the largest, most capable rocket ever built in terms of payload that it can launch into space. And NASA right now is planning to return to the moon. When they're going to return to the moon is a bit of a controversy. I'll talk about that in a second. But the plans right now called for building a space station in orbit around the moon. And that space station is part of the new lunar program called Artemis. You'll remember that the original Apollo landings on the moon from 1969 to 1972 were called Apollo, the god of the sun. And so the new lunar missions are Apollo's sister, Artemis. And one of the first things that will be done as part of the Artemis program is building a space station in orbit around the moon. And you'll notice based on the nationalities here that this is an international space station. There are NASA components. There are European Space Agency components. There are JAXA, which is the Japanese Space Exploration Agency components. There's Roscosmos. There's a Russian component that's going to be on board on the space station as well. So this will be an international space station in orbit around the moon. And the goal is that astronauts will fly from Earth to the space station on the Orion crew module. We will send logistics modules that will bring up food and supplies for the astronauts. And then from here, astronauts will take a lunar lander down to the surface. And unlike the 1960s and 70s, when we spent 2 or 3 days on the surface of the moon, we will now be spending 2 weeks at a time on the surface of the moon, and possibly even longer. The plan for right now is that President Trump has asked NASA to land the first humans on the moon before the end of his second term, if he's elected to a second term. And so right now, NASA is planning to land astronauts on the surface of the moon in 2024 on the Artemis 3 mission. The Artemis 1 mission was supposed to come later this year. It's probably not going to happen until next year, is my guess. Maybe not even until the year after, but that was an uncrewed mission with no crew on board. The Artemis 2 mission will be a flyby around the moon with a crew on board. And then the Artemis 3 mission will be the first landing. First time we've landed on the moon since 1972. It'll be a 30-day mission, and they will spend 7 days on the surface of the moon. And then future missions will spend longer on the surface of the moon. And then the goal for Artemis 8 is to begin depositing materials on the surface for a long-term surface outpost. But we'll see what happens. All of this is in flux, and it all depends on the Congress, the funding that is allocated by Congress. All right, back to our exploration of the solar system. Let's move on to talking about Mars. There is a remarkable amount of things going on at Mars right now. There are in orbit around Mars. This is just in orbit around Mars. There's the Mars Reconnaissance Orbiter, a NASA spacecraft, which is studying the surface of Mars. And then the Mars Odyssey spacecraft, which is another NASA spacecraft, which is studying the atmosphere on Mars. There is the MAVEN mission, which is studying the atmosphere on Mars. There is Mars Express, which is a European Space Agency mission. There is an Indian mission from India. MOM, the Mars Orbiter mission, is in orbit around Mars right now. And then there's the ExoMars mission as well. So there's a whole bunch of missions in orbit around Mars. There are 2 spacecraft that are operating down on the surface of Mars. One is the rover Curiosity, which landed on the surface of Mars in 2012 and has been operating for 8 years now on the surface of Mars. And that is the rover Curiosity. It is searching for past evidence of water on the surface of Mars. And when we talk about Mars later in the semester, we'll spend a lot of time talking about Curiosity. Also operating on the surface of Mars right now is Mars InSight. InSight is a probe to tell us what's going on deep down inside of Mars. And there are 2 main scientific instruments on board. There is a seismometer, a seismograph. The most sensitive seismograph that has ever been launched into space is sitting on the surface of Mars. And then a MOLE, a probe, which was supposed to dig deep down under the surface and deliver a heat flow probe to measure the amount of heat that is coming out of the core of Mars. And that would help us understand whether Mars still has a molten core or not. Here is the seismometer sitting on the surface of Mars. It has measured some Mars quakes, and those Mars quakes allow us to determine the composition of the inside of Mars and the structure of the inside of Mars. Here is the probe. Unfortunately, we've been having a lot of trouble getting the probe to bury itself. It was supposed to use a little hammer to dig itself down, but it turns out the soil is not behaving as scientists expected, and they've been having a hard time getting that probe to bury itself underground. So they're still trying to debug and fix that. And of course, coming up here in about a month, in fact, almost a month from today, we are expecting to launch the next rover to Mars, and that is the Mars 2020 rover. It's now been given a name. It's called Perseverance. The Mars 2020 rover is specifically designed to look for past or even present evidence of life on Mars, microscopic life, and is being sent to a fascinating place called the Jezero crater on Mars. This is the rim of the giant crater, and there's a place in the rim where it was cut, and it was clear that there was an old river here that cut its way through the rim of the crater, and sediments used to flow into the low-lying crater. And what we see today are the sediments that were left over by that flowing river. This is a clear indication that there was once liquid water here. And if there was once liquid water, maybe there was life. And so the Mars Perseverance 2020 rover is going to land on these sedimentary deposits and is going to study them and look for past evidence of life and even possibly current evidence for current microbial life on Mars. So it will arrive in early 2021. All right. Beyond Mars in the solar system, so here's Mars. So Mars is here in the solar system, but they sort of blew it up here so we can see the details. So we've talked about Mercury, Venus, Earth, and Mars. Now let's talk about some of the asteroids in the asteroid belt. There are two interesting asteroid missions going on right now. One is called OSIRIS-REx. It is a NASA mission, and the goal is to retrieve samples from the surface of an asteroid and bring those samples back to Earth. And that asteroid's name is Bennu, and there is an image of what Bennu looks like. Bennu is a really fascinating object. It is essentially a giant rubble pile. It has been hit so many times in history that the rocks have been crushed and broken and crushed and broken. It's held together by gravity, but there's no giant solid core to this thing. It is literally just crushed and broken rock all the way down to the center. And when you look at the surface, this is what the surface of Bennu looks like. Really remarkable. Just as I said, crushed and broken rock altogether. Now, Bennu is really remarkably small. To give you an idea of how small Bennu is, here is the grounds of the University of Virginia. So here is the lawn, of course, with the rotunda right there, and Old Cabell Hall right there. So that is the stretch of the rotunda, the lawn right there. So that is the lawn, and that is about the same size as Bennu. Bennu is just a little bit bigger than the central grounds at the University of Virginia. So really a remarkably small object. It's interesting, though, because Bennu is a near-Earth asteroid. It does make close passes by the Earth. And so we're interested in studying these things specifically so that we can learn more about them in case we find ourselves ever having to divert one of them. Another interesting asteroid mission is the Hayabusa 2 mission that was launched by Japan. Hayabusa 2 was also a sample return mission. It sampled an asteroid in the asteroid belt, and it is bringing those samples back to Earth. And in November of this year, in November of 2020, Hayabusa 2 is going to land back on Earth with its samples. Continuing on out in the solar system, so now that we've covered the asteroid belt out here, we are going to go out and talk about Jupiter. And right now in orbit around the giant planet Jupiter, we have the Juno probe. Juno is studying the interior of Jupiter to teach us more about what is deep down inside the planet. And it is doing that using studies of Jupiter's magnetic field, which is generated deep down in the core of Jupiter, studying Jupiter's atmosphere from the surface, and then using radio waves as well to study the interior of Jupiter. So here are all the instruments that are on board. You've already seen an image from JunoCam, which is the camera on board this Juno spacecraft. We saw that when we were studying eclipses. I showed you a couple spectacular images of Jupiter, one with the giant shadow of one of its moons, Io, on the cloud tops of Jupiter. That was taken by the Juno mission's JunoCam. And here are some of the other instruments that are on board Juno to study the interior of Jupiter. So it's going to measure Jupiter's composition, its gravity field, its magnetic field, its magnetosphere, which is what happens when that magnetic field comes off the planet out into space. It's going to study the distribution of mass in the planet so we can learn more about the structure of the core, the winds down inside the planet, and also its water content. Right now, we do not have any spacecraft studying the 4 giant moons of Jupiter, Io, Europa, Ganymede, and Callisto. We are, however, in the process of planning and building a spacecraft to go to Jupiter's moon Europa. And I'll spend more time talking about this mission later in the semester. I think it is actually the most exciting planetary mission coming up. Europa is an icy moon. And when I say icy, I mean water ice. The surface of Europa is white, and it is made of frozen water ice. But there are many places on the surface of Europa where that ice is cracked. And those fractures have filled in with something. And that thing that has filled them in appears to be a dark material that has welled up from underneath and then frozen. And we think that that dark material is evidence of a liquid water ocean underneath the icy surface of Europa. Now, a liquid water ocean would be interesting because if there are volcanoes deep down at the bottom of that ocean, there is the possibility of life. This is where we believe life developed on Earth. We believe that life developed around volcanic vents at the bottom of our ocean. And it's possible that Europa, if it has a liquid water ocean and if it has volcanic vents, it too may have life down there, deep down under the icy surface. To get there, though, we'll have to get through the ice, and that's a problem because there are competing ideas amongst astronomers as to whether the ice is thick or it's thin. The thin ice astronomers believe that the ice is only 10 to 20 kilometers thick with a warm water ocean underneath, and the thick ice scientists believe that the ice is actually 80 to 100 kilometers thick. That's about 50 to 60 miles thick. In any case, we don't have the technology right now to drill down through that ice to get into that liquid water ocean. That is what your generation is going to have to figure out how to do. What we are doing right now is we are building a mission called the Europa Clipper. It is the first in a series of missions that NASA is going to build and launch called the Ocean Worlds Exploration Program. Thanks to the Voyager spacecraft, the Galileo mission to Jupiter, the Cassini mission to Saturn, we now understand that many of the icy moons of the outer solar system have liquid water underneath their surfaces. And so the Ocean Worlds program is going to start studying these icy worlds, and the Europa Clipper is the first. The goal right now is to launch Europa Clipper probably sometime in the early 2020s to get to Jupiter in the late 2020s, maybe early 2030s, and conduct about 45 close flybys of Europa over 2.5 years, coming as close as 16 miles, but most of the passes will be further than that. And the project is projected to cost about $2 billion, $2.1 billion. And that's what the Europa Clipper will look like. It will have radar that can penetrate through the ice to tell us how thick the ice is and what's underneath the ice. It will have cameras for studying the icy surface. It will have devices so that it can actually fly through some plumes of material that we have been seen to be released from the surface to determine, as we fly through those plumes, we'll actually be able to sample it and tell what they are. All kinds of interesting things will come from the Europa Clipper mission. All right, the next mission we want to talk about is the European Space Agency's Jupiter Icy Moons Explorer, or JUICE mission. This is another mission that is going to go to Jupiter and study its icy moons. It's supposed to be launched in 2022, arrive at Jupiter in 2030. It'll fly by Europa a couple times and then do multiple flybys of Jupiter's moon Callisto, and it will enter orbit around Ganymede in 2033. And then sometime in the future, hopefully we will see a Europa lander. I certainly hope that this happens in my lifetime. The goal here is to land on the surface of Europa, directly sample the ice, directly sample some of this material that has welled up from underneath, and look for evidence that there is life on Europa, either today or in the past. So this is an artist's impression of what that might look like. Then finally, as we get to the outer solar system, it turns out things get fairly slim out here. Right now, there is no spacecraft in orbit around Saturn. We do not have a mission at Saturn right now. Sorry, there's Saturn right there. We did have the Cassini mission at Saturn, but that ended a few years ago. There are no immediate plans to go back to Saturn. And then there are Uranus and Neptune, which were each visited once by the Voyager 2 spacecraft. Each one was visited by Voyager 2, but we have not been back to either Uranus or Neptune since. NASA is considering future missions to Uranus and Neptune, but again, there are no immediate plans to go back to Uranus and Neptune. And then finally, out here at the edge of the solar system is Pluto. Pluto has been visited by a spacecraft once by the New Horizons mission in 2015. We will learn a lot more about Pluto when we talk about the icy bodies out there at the edge of the solar system. But after it flew by Pluto, the New Horizons mission a few years later, in early 2019, flew by a cold, icy body out there at the edge of the solar system, one of the Kuiper Belt objects. It has now been given the name Arrokoth. So out here beyond the orbit of Pluto, there is an icy belt of objects called the Kuiper Belt. These are cold, icy bodies, primarily made of water ice, and Arrokoth is the first Kuiper Belt object that we have ever visited. Although many people would consider Pluto a Kuiper Belt object, Pluto would be the largest object in the Kuiper Belt. Arrokoth was significantly smaller, but was visited by the New Horizons spacecraft. So that is a grand tour of the bodies in our solar system. We will spend more time later in the semester talking about each one in detail in turn, but I just wanted to sort of lay out there what the solar system looks like, the bodies in the solar system, and most importantly, give you a flavor for the amazing robotic missions that we have out there exploring our solar system today. In our next lecture, we will study the formation of our solar system and try and understand how it is that our solar system ended up the way it did. So I will see you in the next lecture.